Hello friends, welcome to UGC PG program. I am Dr. Ushvinder Kaur from Swami Shraddhanand College, University of Delhi. Water quality, pollution and contamination of surface, ground and coastal water systems, problems of salinity and alkalinity. Water is used for various kinds of purposes and the quality is referred with respect to the usage, for example, fisheries, agriculture, domestic use, industrial, etc. Quality is an important parameter in assessing water's suitability for use, for example, whether it is fit for human consumption or for agriculture. Thus, the sensitivity of a particular crop to the dissolved metals, minerals and toxins in the water resources would determine the selection of crops. Poor water quality not only affects aquatic life, agriculture and well-being of people, but also surrounding ecosystems. According to Global International Water Assessment Report 2006, the most polluted drainage basins are the Mississippi Basin, parts of West Africa, Atlantic seaboard basins of Brazil and Congo, and Lake Victoria basins and the Murray-Darling and drainage entering the Great Australian Bight, Baltic and Black Sea drainages. Some islands in Indian Ocean, Caribbean and Sea of Japan are also impacted. Water quality is an important parameter which determines the usability of a water resource for a use, be it agriculture, domestic consumption, drinking and industrial usage, especially in food industry. It relates to specific physical, chemical and biological characteristics of water and determines the ecological health of the system. The physical character of water quality are primarily temperature, salinity, alkalinity and the amount of material suspended in water which influences its turbulence. Chemical characteristics include pH, dissolved oxygen and concentrations of insecticides, herbicides, chemical fertilizers, oils, pesticides and heavy metals. Biological characteristics includes phytoplanktons and excess growth of algae which smoothers coral and leads to poor growth of sea grasses. In India, 63,378 rural areas having over 3.6 crore population are living in areas exposed to health hazards related to drinking water quality. The water quality is poor and has higher amounts of fluoride, arsenic, iron, nitrate or salinity. As stated by Mr. Ram Kripal Yadav, Union Minister of Drinking Water and Sanitation on 15th December 2015 in Parliament. He also stated that 1,318 rural habitations were arsenic affected. Having arsenic levels much higher than the permissible limit in drinking water of 0.05 milligram, he suggested that states to install community purification plants which can provide 8 to 10 liters of water per capita per day, especially in arsenic and fluoride affected areas. Government of India is also planning to provide piped water supply to 90% of rural population by year 2022. In general, water quality is degrading globally and there are varied responses to in different parts of the world. This issue needs to be addressed not only in terms of human health but also in terms of ecosystem health. Water pollution. Water pollution can be broadly defined as presence or introduction of undesirable substances in environment. The contamination of water, air or land by harmful, poisonous and environmentally degrading substances generate unhealthy and unsuitable conditions for all living beings and serious implications on physical environment. Pollution is mostly caused by human actions and occasionally by natural causes. A natural cause could be volcanic eruption which generates dust, debris, smoke, etc. Human causes are manifold: industrial discharge, sewage, chemical spills, agricultural runoff, etc. These can contaminate water bodies such as rivers, ocean, lakes and even underground water channels, rendering them unfit and unsafe for human consumption, detrimental to the aquatic ecosystem and health of organisms as well as toxic for the environment. Water pollution by natural sources. Pollution by natural source is mainly as a result of certain processes of nature which has an impact on the surface, ground and coastal areas. The pollution can be from one source point like a volcanic cone eruption or a non-source point like in landslide prone areas cause damage to soil, and there is a movement of gravel and vegetation from the concrete buildings destroyed in landslides. Water pollution by human sources. Water pollution can occur from variety of sources. However, broadly, two terms are used to identify how water gets polluted. Firstly, point sources, in which pollution is from discrete locations. It can be a single sewer pipe discharge or a factory or an industrial unit or a runoff from a single farm. For example, the oil spill of Bharat Petroleum in 2010 is a point source pollution. The single point leakage of massive amount of oil into water body, the location of pollution and its source are unidentifiable and can be legally controlled through legislations. Secondly, non-point source pollution, in which these several points of contamination over a large area and therefore no single source or point generating pollution. The water bodies like river, lake, ponds or sea or ocean are contaminated by multiple sources like urban discharges, agricultural runoff in form of pesticides and fertilizers, etc., oil spills and industrial untreated discharges. The non-point pollutants pollute the water and sources through drainage, land runoff, flood, precipitation, seepage or hydrological modification, atmospheric depositions, etc. Since the source of pollutants is not easy to identify, it makes it more difficult to regulate. For example, the Yamuna, the Ganga and the Mississippi rivers are water bodies where there is evident risk from non-point source of pollution, because these river systems are very large and exposed to variety of pollution sources. Pollutants in water. Pollutants in water can be categorized into organic, inorganic, biological and natural pollutants on the basis of their nature. Organic pollutants include fats and grease and oxygen demanding substances which are generated as waste from food processing units. Chloroform, which is used as a disinfectant in drinking water, can cause disinfection byproducts. Chlorinated solvents are denser than water and may sink to the bottom of the reservoirs as they do not mix well with the water. Industrial solvents improperly stored can leak into water sources and can include volatile organic components. Herbicides, pesticides, insecticides have large composition of organic and other chemical compounds. Debris from forest cutting sites like timber, bushes, leaves and branches, etc. can cause pollution in water channels. Perchlorate and terichloroethylene ethylene are also industrial pollutants. The United Nations Program Governing Council in 1995 has identified 12 persistent organic pollutants, also referred to as dirty dozen. They include DDT, eldrin, endrin, carcinogenic, polycyclic, aromatic hydrocarbons, etc. They are resistant to environmental degradation and capable of long-range migration into biomagnifying food chains and impacting environment. Inorganic pollutants include copper, zinc, lead, nitrite, phosphorus, ammonia, phosphate, which have iron traces in the environment. These pollutants enter water sources through industrial discharges from power plants in form of sulfur dioxide, nitrates and phosphates from fertilizers. Runoff from residential and commercial uses, ammonia from food processing units, discharges from mining sites and emissions from motor vehicles. Biological pollutants include viruses, house dust, pollen, bacteria, etc. A biological pollutant can originate from various sources such as chloroform, bacteria from plants and soils, or from the warm-blooded animals including humans, pollens from plants, viruses from human and animal, etc. Radioactive pollutants are generated by nuclear reactors, mining, radioactive geological formations, industrial waste sites, medical treatment, diagnosis, weapons, etc. Some of these also generate tremendous amount of heat. These kinds of pollutant in water cause various kinds of cancer and damaged tissues in human and other organisms. They consume those who consume the contaminated water. Surface water pollution. Surface water consists of water channels above the ground such as rivers, lakes and streams. The surface water becomes polluted mainly by rainwater runoff, which creates various kinds of pollutants along with it into aquatic systems such as salts, chemicals from industries and fertilizers, and nutrients from agricultural farms and gardens. That is called as nutrient pollution. This causes overproduction of algae, which creates layers over the water surface, thereby hindering sunlight penetration to the underground water plants and aquatic organisms. This leads to lower levels of oxygen generation, causing problems to regarding oxygen breathing organisms like fishes. The sewage leaks and the runoff from the slaughterhouses and animal farms and the factory discharges cause pathogens which create waterborne diseases. The bacteria and viruses that pollute the surface water channels cause dangerous human health problems such as hepatitis and thyroid and typhoid. The pesticides, lead, arsenic, mercury from the mining sites, synthetic chemicals from other motor vehicles are also very dangerous for environment, also deteriorating the health of organisms that inhabit them. With the growth in population in many parts of the world, especially in developing countries, and improvement in standard of living, there is increase in demand for fresh water. On the other hand, pollution from agricultural, industrial and urban areas is also increasing, rendering water resources not suitable for consumption. In certain areas, rivers have become biologically dead and poisonous, with ammonia levels soaring, making them unsuitable for drinking. It is estimated that 5 million deaths each year in developing countries due to water related diseases, which could be prevented by adequate supplies of clean water. Surface water bodies, especially rivers, need to be analyzed in totality, including the river basin or the catchment area. They are complex ecosystems with millions of pollution causing sources around them. The awareness and need to reduce pollution is gaining importance, but major improvements will require long durations, in some cases decades, in large river basins. Main causes of surface water pollutants. The major pollutants in surface water systems are heavy metals, toxin, persistent organics and organic chemical generated as industrial waste, human waste through sewage networks, or directly causing occurrences of pathogens in form of bacteria and viruses. Agricultural generated pollutants in form of chemical fertilizers, pesticides, insecticides, etc. might seep into water channels through runoff. Runoff in river systems and surface water bodies can also cause pollutants such as debris. Problem and solutions of surface water pollution. Almost all of the developing countries face water quality problems in major rivers and surface water bodies. The northern rivers of India in Ganga Yamuna basin face serious pollution relating to issues. In China, the rivers like Hui is highly polluted due to uncontrolled industrialization. Smaller rivulets or tributaries flowing through urban areas are the main sources of water for those urban areas, but they also become urban drains or rubbish tips. Many countries are trying to address the surface pollution by learning from experiences of rehabilitation of rivers like Thames and Rhine, which have been recreated and revived with decades of effort. Various action plans have been initiated, like Ganga Action Plan in 1980s. Millions of rupees have been spent but the impact has not been visible. River in center of Shanghai has spent billions of dollars for cleaning and relocation or closure of many polluting industries in last 2 decades. Groundwater pollution. Water bodies is estimated to serve 20% of global population. Groundwater aquifers are slower to show the impact of pollution, but the contamination is far difficult to solve. So, difficulties to control and monitor pollution levels. It was earlier thought that the layers of soil and sediments would filter all the impurities before the water reaches the aquifers. But in 1970s, it was realized that impurities still seep into the aquifers and thereby contaminating the groundwater. Once the underground water is contaminated, it becomes unfit for consumption and would require decades to normalize. There is no quick and inexpensive method to clean groundwater channels. The contamination can occur naturally by metallic or mineral deposits in soil or rocks. For example, toxic metal arsenic found in sediment rocks in many parts of the United States can cause excess level of arsenic contamination in drinking water exceeding the safe limit. Coastal areas have problem of saltwater intrusion wherever the rate of groundwater pumping is high and seawater invades the freshwater aquifers. Types of groundwater contamination by humans. Human activities generate two categories of groundwater pollution: point and non-point source pollution. The point source pollution relates to contamination from a single source, such as a spill from a tank or leaking oil tankers, gasoline storage tanks, disposal facilities or industrial waste disposal sites, landfills or dumps. The non-point sources of pollution are spread out and impacts large areas. Excessive use of chemical in form of herbicides, fertilizers, pesticides over large agricultural area eventually reach the underlying aquifers. The impact is high in regions where aquifers are shallow and the surface is covered by very permeable material, thereby speeding the penetration into the ground aquifers. The surface covered by clay are low in permeability and they can help to reduce penetration. Runoff from urban and industrial areas also cause non-point source of pollution. The impact of non-point source of pollution affects water quality over a large area compared to point source pollution. The damage to septic pipes can also contaminate large areas. Industrialized areas, there is high risk of contamination by petroleum and chemical products. Chlorinated solvents in form of dry cleaning fluids known as perichlorine ethylene are polluting waters. Methods of cleaning groundwater. Containment should be done to prevent the contaminated water from polluted aquifers to migrate from the source. This can be done physically by using physical barrier of cement, clay or steel underground, or chemically by detoxifying or immobilizing the containment by using reactive substances, etc. Removal of containments from the aquifer can also be attempted, such as metal, pesticides, organic chemicals. Salt intrusion in coastal areas can be reduced by appropriate well field design and also by drilling relief wells to keep salt water away from fresh water. Built-in capacities to detoxify or immobilize the pollutants while they are still in aquifers, and then removal from aquifers by ground extraction wells. This can be done by pumping and treating. It takes a long time to clean up but can successfully remove most of the contamination from the aquifer. Treating the groundwater at the point of its use, depending upon the type of contamination, some groundwater cannot attain safe quality. In case of large water providers, evaporation towers called in air strippers and special filters need to be installed. With the personal well owners can install reverse osmosis filters or whole house carbon filters, totally abandoning the use of contaminated aquifers and finding alternate source of water. Coastal water systems. Coastal water systems have their own set of specific issues, such as alternative water supply projects like aquifer storage and recovery, desalinization and reclaimed water use, which are being explored in coastal areas. There are various types of coastal pollutions and their impact. Impacts of coastal pollution. Coastal pollutions may drastically reduce the tourism business in the region. A species from outside region may become a common, causing imbalance in the local aquatic ecosystem, leading to health problems, changing in the fisheries pattern and interfering with the tourism. Marine life and birds are caught in the waste like plastic bags and rings, oil spills, etc. Large quantities of carbon and nutrient led to plankton blooms. Once the plant die, they sink to the bottom, disintegrate, decay and releases carbon dioxide. thereby reducing the amount of oxygen in deeper waters. Coastal pollution can be non-point pollution characteristics, such as pollution being transported into coastal environments via rivers or streams. Groundwater, the atmosphere, combined sewage flows, flood channels, storm water runoff or leaking septic tanks, etc. Salinity. Salinity is a measure of presence or concentration of total dissolved salt in water or soil, mainly sodium chloride, common salt. Soil salinity is the salt content in the soil, and over time there is a process of increasing the salt, and this is called as salinization. This can occur due to gradual withdrawal of ocean or mineral or chemical weathering of soil. Water salinity accounts for the salt dissolved in water is measured in terms of parts per thousand. The average water salinity is 0.5 ppt to less, whereas the ocean salinity is 35 ppt. The human activities are contributing to salinization of water. The disposal of liquid waste or saline water, waste into the well or basins or solid waste that contains the soluble salts and are present in landfill sites. These can leach by rainfall into the underground water or buried beneath the water table. During extraction of groundwater, it causes intrusion of saline water, as extraction causes disruption of interface of saline fresh water. The use of saline surface water for irrigation can increase the salinity of underground water. If the water returns to underground aquifers as recharge, major causes and activities that increases salinity levels of surface water are following. The salinity is affected by changes in diversions and return flow along with the losses and gains from groundwater in neighboring strata. In highly irrigated areas, there are greater chances of increasing salinity load of streams and rivers. The changes in management of vegetation and soil in non-irrigated areas can cause increased recharge of underground water and discharge of salts in streams and rivers. Construction of canals and reservoirs can cause leaching of salts downstream, and the saline groundwater gets displaced from underlying stratas to streams and rivers. Salinity in arid and semi-arid areas is a major problem, and advancement of deserts due to salinization is threatening agriculture globally. Secondly, salination in arid and semi-arid areas is getting widespread due to overuse of irrigation schemes. It is estimated that 20% of irrigated areas are salt affected. Agricultural crops are severely affected by higher concentration of salts in soil and in water as they are sensitive to salinity. There are serious impacts of salinity on water supplies and soil structures. In most areas, salinity is the outcome of faulty agricultural practices like over irrigation, waterlogging, over use of chemicals in form of pesticides and fertilizers, etc. Problems of salinity. Salinity reduces the soil's capability of particulate matter water into the subsurface, which can cause flooding during the heavy rains. Salinity is a major threat to biodiversity in form of loss of habitat both in water and on the land. Salts alter the in-stream and the biostrata and also change the health of estuaries and streams. Salinity problem is higher in dry and arid environments where the evaporation rates are generally very high, causing salts to leach on the surface. Poor quality irrigation water with high concentration of salts can have greater impact. Salinity increases the maintenance and repair costs of public and private goods like infrastructure, roads, bridges, sewage pipes, housing and industry. Salinity directly affects people in form of increasing costs or rehabilitates saline farms, declining rural population, stress related to lower productivity, etc. Salinity indirectly affects the human by reducing the quality of natural environment. For example, there is a decrease in wildlife in the salinized natural wetlands. Impacts of salinity in water. Salinity in ground and surface water has significant effects on surrounding environment and the health and well-being of ecosystems. Saline soils generally become bare and compact, creating conditions leading to gully or sheet erosion. This generates huge sediment and salt loads in water courses, thereby degrading water quality downstreams. High concentration of salts in water is quite unpalatable for human and livestock consumption. The toxic ions, particularly manganese and sulfide ions in water, can cause gastroinfections, irritation in cattle as well as human beings, and impacts of their production and contaminate milk production in case of cattle. Aquatic ecosystems are significantly impacted by increasing salt content in water. Saline water corrodes the material used in construction of bridges, foundation of buildings, sewage pipes, etc., and can sometimes disrupt the local water supply. It impacts the productivity of rural regions. In urban areas like Wagga Wagga in the outer suburbs of Sydney, saline soil and water is causing rusting in motor vehicles and decaying building foundations. The salty water is damaging the hot water system, septic tanks, household appliances, etc., causing huge losses. The factors affecting saline seeps can occur due to excess water or soil characteristics or both. In dryland areas, saline seepage leads to accumulation of salt in seepage spots at lower points or side slopes in landscape developed areas. In cases water infiltrates into soil having impermeable layers and moves down slope, the water at lower elevation seeps laterally at soil surface, and as water evaporates, the salts are left behind. If the water is in excess of retention capacity of root zone soil, it percolates greater than the root zone and reaches the groundwater, thereby increasing the flow to the discharge area. When the underground water is travelling to discharge areas, the salt from the soil also travels with it. In the discharge zone, the groundwater rises to the soil and water evaporates from the surface, forming the seep. Alkalinity. Water alkalinity can be defined as its capacity to neutralize acid content. Hydroxides, carbonates and biocarbonates are alkaline substances found in water. One or more number of ions is present in water, thereby making the water body alkaline. Some amount of hydroxides are naturally present in water. Their levels can rise due to some treatments in domestic supplied water sources. Biocarbonates are most prevalent source of alkalinity in water. Biocarbonate ions, if in any small amount, will not show alkaline conditions, can only be noticed if large quantities are present. Some amount of carbonates are naturally present in water. Increase in levels of carbonate due to addition of lime soda, which is used to soften the water. Silicates and phosphates are seldom found in natural water supplies, but they are used in various water treatment processes. To balance the cohesive effects of acidity in most water supply, moderate concentration of alkalinity is desirable, but only in moderate quantities, as excess will cause number of problems. Alkalinity can be easily detected even if small quantities of carbonate and hydroxide ions presence. Water severely alkaline has an objectionable soda taste. Calcium, magnesium, potassium and sodium ions needed to be cautioned. The pH potential of hydrogen value signifies the measures of alkalinity or acidity of water soluble substances. The range is 1 to 14, where the middle value is 5, indicating neutrality. The values above 7 indicate increasing concentration of alkalinity, where 14 pH signifies most alkaline. The value below 7 represent increasing levels of acidity, where value is 1, most acidic. The scale is logarithmic scale by factor of 10 in two adjacent values, which decreases or increases. The capacity of water to resist change in pH value is called buffering capacity, where alkalinity suggests the water capability to neutralize acid. Problems related to alkalinity in water. Alkalinity helps to create buffer against increasing component of acidic material in water to protect aquatic life and fishes. Loss or temporary loss of buffering capacity will lead to drop in pH levels to harmful levels for life in water. Most plants and animals in aquatic environment require a specific pH value for their survival. Slight change can lead to mass deaths. The pH ranges between 4 to 10 levels. Any range above or lower will kill most of the fish in water. The living things are very sensitive to changes in pH value. The Michigan State University research identifies that the high pH value more than 6.5 increases the risk of micro content deficiencies, and less than 5.3 pH results in magnesium or calcium toxicity. The ecological study in Netherlands have found out that influx of alkalinity has caused demise of native plants, and in Ohio State University Extension Services that alkaline water can impact the plant capability to obtain nutrients from the soil and also alter the pH levels of soil over time. Acidity is dangerous for human bodies, and increasing levels of alkalinity is equally dangerous because of both cause nutritional imbalance. Few scientists are of a view that normal cells die extensively in alkaline environment. In normal course, the alkaline water mixes with the gastric acid and neutralizes in human body. If there is increasing levels of alkalinity in stomach, they can further dilute the levels of gastric acid, which is helpful in digestion and also kills body parasites. This situation can lead to malabsorption nutrients and cause deficiencies. Thank you.